We'll be starting today with the one of the very much important modules uh, that's called statistics. Uh, Statistics is one of the basic and the heart of the one of the modules, which is the heart of data analytics, advanced data analytics, data science, um, data engineering, computer science, and in all subjects related to computer that you are studying or you will study in the future. So statistics is the basics of that. Statistics covers the basic of statistics, probability, and also the regression, which we will be focusing on these three subjects separately. But still today we will be starting with the very basic of it, which is the understanding the statistics. So there are two types of statistics. One is called descriptive statistics, that almost everyone is aware of it, and everyone is actually dealing with it. And another is inferential statistics. And now let's explore the what is descriptive statistics. You understand the descriptive statistics already. So when you call the function the method describe in Python for a data set, it gives you the summary statistics of what is the mean, median, 25 percentile, 50 percentile, 75 percentile, standard deviation. All these measures have been calculated for you, and you can see that in Python. That's called descriptive statistics. It is actually describe and summarize the data. So it gives you the summarization of the data. For example, 50% of friends drive to work. Yeah. So this is a factual thing. So this is based on descriptive statistics. You can understand, okay, 50% of people, for example, they're driving to work. So these are examples. For example, 25% take the bus. Yeah. So 25% they're biking. So these are all statistics. Now coming to this descriptive statistics is also called summary statistics. Some in some subjects, any other subjects, but we will be calling it descriptive statistics because we are mainly working discussing statistics in Python, using Python, and using we are actually discussing statistics related to the field of data analytics. What is inferential statistics? Inferential statistics is it uses a sample of data to make inferences about a larger population. Look, so what percent of people drive to work? So this is inferential statistics is actually about a type of prediction. So it's actually it's actually not a predictive modeling, but it's totally different here. But this inferences which it makes, this statistics, it is type of predictions. For example, we have in our class, for example, we had 100 people, and this is called population. This is population of our class, and we have a sample of, for example, 20%, 20 students, 25 students, or 27 students, or for example, 30 students, and this is our sample, and we are launching a survey, okay, and saying, okay, how was the previous model, for example, previous model data visualization. For example, 10% says, okay, it was good. 50% says, no, it was not good, for example. 30% others says, okay, somehow fair. So this type of statistics based on this survey has been generated. But this is only within the population side. So it means within the sample side. So only 30% who is now the sample of this whole class, they voted different things, for example. And whenever someone asks me that how was the previous model, if I infer, how is the inferences work? If I give this statistics from this sample and apply it to the large population of the whole class, which is 100 people, and I say, okay, how was the previous model? And I will say, okay, no, around 10% says that it was good. So this is how you're making a prediction, actually, or an assumption based on a sample from a population side. This is called inferential statistics. So this is where probability comes in. So I hope you got it now. This is the definition, official definition. Descriptive statistics summarize and describe the main features of a data set. For example, mean, median, mode. Any questions? Just okay, please mute yourself if no questions. If yes, then just raise your hand or just because I don't see your screen there. Inferential statistics make predictions or inferences about a population based on a sample. So it's called, for example, hypothesis testing. So we will be coming to that, what's hypothesis testing. So you see, we have a data here, look at it. We have a data of oh, maybe what another problem that you are going to have is actually, this is your problem. I hope now it's seen by you. So I just made a bit zoom in. So this is an example data set, for example, student A, B, C, D, E, and these are the marks of these students, for example, yeah? So these are all the marks for these students. We put this data into a framework, a data frame. Then we asked the descriptive statistics on these marks. Look, 5 students, this is 5 marks, the count of marks are 5. Mean average marks are 86. Standard deviation is 5.4. Minimum marks 78. Maximum marks 92. 50% of students are below 88. 75% of students below 90. And the remaining top 25% students, they got numbers between 90 and 92. See, this is how the descriptive statistics works. So this assume that this is only 5 students. And if you have a full class of, for example, 25%, 25 students, and you're assuming now based on these scores, based on these scores, if you're assuming that this is a sample and the whole class, which is, this is only 5 students, assuming, okay, the whole class, which is 25 students, what will be their general performance of students? So based on this is the mean, the average of all schools is 86, which is good. And then you're saying, okay, this class is performing well. But you don't have the scores for all 25 students. You have just scores for a sample of. So this is called now the inferential statistics coming. So this is the difference between the statistics and between the descriptive statistics and between the inferential statistics. Role of statistics in data analytics, it's very critical because it summarizes the data to identify trends and patterns. If you don't understand this, if you don't understand the trends and patterns and data, how you will do the analysis? So that would not be a possibility. Validating assumptions about data using inferential techniques. So you have some assumptions, yeah, all the time. You're predicting something, you're making some decisions, all these, for example, and in the method that we have studied already in 𝗘𝗍𝗹, data, information, knowledge, and wisdom. So based on a wisdom, making a decision. That decision is all the time, those decisions or assumptions, data-driven assumptions. But those decisions should be accompanied by data. Which type of data? Those are all inferential techniques that should be applied on those data, and then you make some large assumptions based on a sample of population. And supporting decision making with predictive models, which is, I just mentioned to you, this is the wisdom part that the data brings to us. I used here, for example, a standard data set. It's called IRIS data set. It's a very interesting data set. All students from different data analytics site, they're using this data set. This data set is actually built-in data set within the Python. So in Python, there is a library called sklearn. So this is scikit-learn. Scikit-learn library is actually type of a scientific toolkit for the Python. It's like pandas, it's like like NumPy, like 𝗔𝗱𝘃, in any other type of libraries. And it's a huge library which supports different types of modeling, statistics, probability. In all time you will be using that. This is one of the libraries that we will be using. Another library is called SciPy. SciPy is also scientific, science-based Python library, which we will be using for inferential statistics. Also it's also we can use it for the descriptive statistics as well. So these are different libraries. So from this standard, this scikit-learn skill-learn library, it has pre-built-in data sets there. So from that data set, we load iris data sets. So this is iris data set. So just we put the data iris data, we just load it, and this is iris data frame. So we just put it in the data frame, and this is the data set overview: sepal length, sepal width, petal length. So this is about the plant standard data set. Now this is only the overview of it, and this is the summarization of data set. Look at this. So petal width of this specific, for example, species. There are 150 in the data set. The mean average is 1.19 centimeter. Look at this. This is the measure centimeter. Standard deviation is 0.7. Minimum is 0.1. Maximum is 2.5. So this is how you get the whole summary of this huge data set here in Python. This is how, why I bring this, that we will be working with this data set sometimes. Then you have to understand how to load the iris data set. And this is a data set about the plant, specification of the plants. Now coming to the key terms in statistical overview of key statistical terms. So these are very important that you have to understand it properly. First of all, population, entire group that you are studying. For example, all students in a school, all students in our class. For example, population of a country. Look, these are all the whole population, which is impossible for you to go and survey all of them together. So that's population grouping. So this is called population. It's very difficult, for example, to launch a test or just launch something for the whole population of a specific country. Yeah. Sample is a subset of the population. For example, we had 100 students, and subset of these students, for example, this sample is actually, for example, you can define it maybe 10% of it, 5% of it, 15% of it, just a subset of the population. It depends on that as well. And variable, it is characteristic which is measured already. So that's called variable. You already understand that, and we, with the Python that we have started, we studied what's variable. For example, height, marks, age, all these things are variables for the subset of for the sample, for the entire population, for the subset. And what's parameters? Parameter is a numerical summary of a population. So average height of all students, for example. Look, this is in this example, for example, this is student A. These are students A, B, C, D, E. These are marks. Look, these marks, these are all variables. Yeah, these marks are variable for what? For sample. But if you're doing any inferences from this sample and referring it, describing a whole population, then that would be becoming a parameter. What is parameter? Parameter is that, look, average of this sample, it says 86%, 86% of marks. Then you're inferring this sample and says that all students in this class are performing well, and their scores on average are around 86%. Look, from this sample, we inferred to the whole population, and this 86% that we are just inferring to the whole population from the sample, that's called parameter. What is a statistic? That's numerical summary of a sample. So this was a statistic. This is a statistic. See, numerical summary of this sample. This was the sample of our students here. So this is how the difference of these key terms that you have to understand. Now look at this. For example, we have population of we just generated random students. Yeah. Marks of 100 students. Yeah. So this is the population. Sample marks of 10 students. Yeah. Now we want to print the population mean in the sample mean. Look at this. Sample mean is 79 marks percent, and population mean is 73. Look at this. Why I printed this one here? It's important. For example, if you do that. This is just population. This is 100 students. 100 students with different marks. And this is only 10 students with different marks. So we got, this is the whole population. We got this sample. We calculated the average mean of value for this sample. We calculated the average mean of value for this population as well. Look, why we are doing that. If I calculated, if I don't have, for example, this marks for all this population, yeah. If I have only sample, this is my sample, yeah, and I have marks for this sample, okay, and I say, okay, average, the mean, which is mean of these values, or 79%, and I say, okay, good. I'm assuming that this class is performing well, and around 79% of then there is a confidence interval. We will be discussing that. What's confidence interval? That we are saying maybe plus minus 1.5 or 3%. And we are, for example, saying that 95% I'm confident that on average, this class is performing well, and the average scores are around 79.3%. You got, so from this sample, you made, which is statistics. You made an inferential. What is called, you wanted to predict something for the whole population. Now assume that I have now the marks for the whole population as well. Now let's see how much I was right. 79, 73. It's almost there, but it depends on different. We just randomly calculated this. By all time running this again and again, this will be changed. Look at this. This is changed again. It's changed again because this is random data set that we are generating. So this time, see, population mean is 75%, sample mean is 72%. What does it mean? It means that from a sample size, we can predict the whole population size, the parameter of a population as well. So from a statistics of a sample, we can predict the parameter of a population as well. But this is how you have to understand between the sample size and between the population size. Now, coming to the one of the interesting things that you have already studied, that's called data types. So data types are matters very, very well, and you have to understand it very well. We are just we will be proceeding not in depth with the data types. We will be just passing the data type very rapidly because you have already a proper understanding of what are different data types are there. You see, the whole thing that we have started, these models, all of them are linked together. So the first things in Python that we have started, it is actually also works for the statistics as well. So we have types of data, we have quantitative data types, and we have qualitative data types. Quantitative data or numerical data that represents quantities, for example, age, height, different things. And within the quantitative data, we have two other subcategories. Which is one is discrete and another is continuous. Discrete is countable values. For example, number of students, yeah, number of books, for example, number of notebooks, for example. These are discrete values which are countable measures. And measurable values, continuous, which are measurable values, these are not countable, but they are measurable. You have to measure it. For example, temperature. You cannot say, I have 32 count of temperature. Yeah. So you cannot count temperature. Yeah. You have to measure temperature. Pressure, for example. You cannot count pressure. How can you say, for example, how much bar, how much Pascal pressure is, for example, but you have to measure it. So measurable values are called continuous measures. And qualitative data, it has categorical data representing labels or characteristics, for example, gender, nationality, for example. These are categorical data. For the categorical data, we have also two types. We have nominal data and we have ordinal data. Nominal data, these are categories without order. For example, you have categories or eye color, for example, color of something, for example, different categories you can have, for example, but orders are not important there. That's called nominal categorical values. But if orders are important there, then those are ordinal categorical values. Why it's important? For example, education level. In the education level, you cannot say that order is not important. Order is important, for example. Yeah. So you have to go from lowest to the highest or from the highest to the lowest. So these are the type of data that you have to understand. So this is a data set that we have created a similar thing. For example, a data set of name, age, height, city, grade. These are names, ages, height, cities, and grades, and we converted to the data frame. And then within the data frame, we started to understand which type of data is this one, for example. So age is quantitative data, but this is discrete data, for example. Height is quantitative data, but this is continuous because height, you have to measure it properly. Understand? So you cannot count it. You have to measure it. And it can be measured in different measurements. So I really don't know. This is right now maybe 5.5, maybe in foots in inches, for example. But you can have it in meters, you can have it in centimeters, different values. So qualitative data, cities are qualitative data, but they are nominal. Order is not important. Which city comes first? That's not important. But grades, these are important. These are qualitative data, ordinal qualitative data. Grades are important. There is an order. A is first, C is last. So B, A, C. So these are orders. So you have to take it on. Now coming to the levels of measurement. So we have nominal, ordinal, interval, ratio. How to measure something, for example. We say that okay, these are the quantitative values. These are continuous values, and you have to measure it, for example. Now, how to measure it once? Nominal scale, for example. We have to have some scales, and based on those scales, we have to measure something. For example, nominal scales, categories without any order, for example. These are levels of measurement. For example, nominal measurement, ordinal measurement, these are from categorical values. Interval and ratio, these are from the quantitative values. Look at this now. What is nominal scale? Nominal scale is categories without any order, for example. So categories, these are categories without any order. Ordinal scale, these are categories with an order. Yeah, so rankings, these are rankings, grades, A, B, C. Interval scale, these are numerical data with no true zero, equal intervals, temperatures and Celsius. So these are interval scales. So you have to have intervals, yeah? So from temperatures, for example, from 1 degree to another degree. or temperatures in different intervals. For example, temperatures in Celsius and temperature in Fahrenheit, for example, or maybe in Kelvin. I don't know, no one is now measuring it in Kelvin, but just as an example. So these are how you can, based on an interval, you can scale it. So now the how to scale a numerical data. And the issue scale is a numerical data with a true zero. For example, weight, height. So these are the true zero means that you can, based on a ratio, you have to scale it, not based on an interval, based on a ratio that you have to scale it. And that ratio is actually, for example, is applicable to the weight, is applicable to the height. So this is how you have to understand. For example, look, nominal data, this red, blue, green, red, blue, these are nominal. These are categorical values, but these are nominal ones. Order is not important. Ordinal data, low, medium, high, medium, high. So these are categorical values. Order is important. Interval data, which is temperatures. So interval data 15, 20, 25, 30, 35. These are temperatures. And how to scale those temperatures, then you cannot scale it in a specific way. You have to have it based on an interval. For example, um, uh, degree of temperature between 0 to 5, for example. This is an interval. Degree of temperature between 5 to 15, for example, or 23 to 33, above 33. So this is different types of intervals that you can measure properly. You can scale these measures. And ratio data, which is type of um, continuous data, but with true zeros, for example. So this is ratio data, 50, 60, 70, 80, 90. So this is different weights, so kilograms, yeah? So it comes with them. You cannot say from this ratio to that, from this interval to that interval, but you can just say from this weight, so it's specific in this category of weight. So these are ratio data. You can, these are all theoretical terms. It will be a bit difficult for you to digest it right now, understand it very well, specifically for the students who are not coming from uh, a science background, for example, maybe engineering, maybe mathematics or anything. So that would be a bit difficult, but still you have to have it in your mind, at least theoretically, to understand that what are these things are meaning. Look, for example, we have um, ratio data example, for example. These are weights, yeah? So individuals in different categories and different ratios, and these are weights, yeah? So this is different types of individuals, length ratio data, and ratio data, the colors. So X label is the individuals, and this is the weight. So different types of individuals in categories in different ratio of having different ratio weights, for example. This is category, for example, number 3, and the ratio of weight is, for example, this much. This is the category number 4, where the ratio of weight is over, for example, 90 kilogram. This is the category 0, the first one, which is the ratio of weight is below, for example, 50 kilogram. This is category 1, which is the average mean of weight is actually 60 kilogram. This is how ratio data is working. This is just a understanding of how you can visualize that. We can have identifying data sets in the real world. So this is a data set. Look at this. I just want to bring to your attention how to load a data set from a link. This is a link of data set. See, this is a Pythonic data set. So if this is the link to that specific data set, you have to post this URL and equal to this specific link. Then Titanic div, which is data frame, it will be pd.read_csv equal specific. Instead of having that specific place from your computer, you can provide a specific link to that of that data set here as well. So I just post it here, and then this is the Titanic data set. So just run it again. Let's display Titanic div properly. Mm, this is Titanic data set. Got it. This is passenger ID survived or not survived. 0 not survived. 1 survived. So this is Boolean class. See? P class passenger class. Which class the passenger was? Third class, first class, second class. These different classes. Name of passenger, gender of passenger, age of passenger, siblings were there or not. Arch, I really don't know. Maybe what is this? I don't know this one. Ticket, this is the number of ticket. Fare, how much was the cost of the ticket? Cabin, does it have cabin? Embarked, where embarked? Which station? These may be the name of stations. This is how this data set looks like. So you can just bring the data set from the different types of now let's explore, for example, the data set. So who can tell me what is the passenger ID data type?
It's an integer or number.
Integer?
It is integer?
Yes.
It is qualitative data or quantitative data?
Quantitative.
It's
Quantitative.
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 Uh-huh.
And Professor, PARCH stands for parents or children, the number of parents or children. So whether the passenger had parent or children on board.
Yeah, thank you. Good. Passenger ID, it's who says that it's a quantitative value or is a quantitative value?
It's quantitative and
Everyone says the
Because
passenger.
we cannot because we can count it, so it is quantitative.
I think, sorry, last time I said it's quantitative,
Qualitative value also can count.
Because this is like we are not counting the IDs. We are just like saying like indexing by IDs. Okay, so this is like just a category or like a list index. So it's qualitative.
Yeah, indexing is also an interesting point that this is because the index, but passenger ID is not here the index. The index of this data frame is this is the index.
Sir, I would say the passenger ID would be considered quantitative, but at the same time discrete. Originally, we would say that these are unique identifiers of each passengers within the data set.
Yeah, I'm just making. Okay, now the P class, passenger class. So who tell me, so this, we have, for example, here 3 classes, 1, 2, 3 classes. This passenger class, which type of data is this passenger class is?
Qualitative, sir.
Why qualitative?
Quantitative, but I think it's interval.
Sorry?
Interval.
It's qualitative and ordinal data type.
Mm-hmm.
Because we
Okay,
have class A, B, C, or like should be class for. So we have different classes. Like if you suppose like airplane, business class or middle class, something like this. So that's why it's qualitative and it's ordinal.
in ordinal. And okay, so this fare, this one, which type of data is this fare?
Quantitative.
Quantitative, sir. Yeah.
Quantitative. Which type of quantitative?
It's quantitative continuous.
Exactly. Okay, good. So I get that you have understanding of data types, but there are some still misunderstandings. Some points. Now let's go to this. This passenger ID is actually a quantitative data. This passenger ID. Because it's 1, 2, 3, 4, 5, but this is discrete quantitative value. So what is actually discrete and continuous? Discrete is countable quantitative value. So these are the counts. So this is the passenger ID. Until it is quantitative, if you're counting it, for example, or doing any statistical summaries based on it. But if you're using it as an index, as one of your colleagues said, then it will not be counted as a quantitative data. It will be a qualitative data, because if you're using it for indexing, then that's qualitative data. You got it? If you're doing some statistical, mathematical operations on any numbers, then that would be type of quantitative, but which is used for aggregation. If not used for aggregation, it's used for categorization, then that would be the qualitative data. So here is from the data point of view that we have studied, passenger ID can be counted, for example, as a quantitative data, because this is 1, 2, 3, you can count it, you can sum it as well, you can have some of these passengers. So based on this, but also you can say that this is discrete, not continuous, discrete because countable. Now coming to the passenger clause, one of your colleagues told me that this is A, B, C, this is categorical value, and this is ordinal categorical value, because number one class is the A, category A, number 3 class is the category C. As he said, the business class name, this is qualitative data, and this is nominal qualitative data. So there is no order, is not important. Age is quantitative data, continuous quantitative data. We understand this. This is 22 years. You can, this is continuous, you have to measure it. And then fair is a quantitative data, but this is type of, as you said, look, this is quantitative, but this is type of ratio quantitative data. Yeah, so we have interval quantitative data, and this is that's from the scale point of view, and we had the ratio ones. Yeah, so this is not an interval based, but this is based on ratio ones. And embarked, which is the number of the name of stations from which the passenger got to the Titanic ship. It is qualitative and nominal. So this was just a small experiment of how you have to understand the data types. Now coming to the measures of descriptive statistics. If you're going to the descriptive statistics, I hope data type is now cut and clear. Please go and review it again and understand it properly, because whenever you are dealing with data sets and whenever you are analyzing the data set, specifically mainly when you are predicting data for the future something, then you have to understand the data types properly. And because whenever you're doing some feature engineering, you're introducing new features, new columns. So those understanding of data types are very much important, and how to manipulate those type of data in order to generate new features. Those are playing a key role. Now coming to the next chapter, which is descriptive statistics. And from this descriptive statistics, the first thing which comes to our mind, it's called measures of central tendency. I prepared some documents, lecture notes for you as well. So I will be sharing that as well with you. So this is a very basic notes, whatever I'm saying. So these are the notes which I collected from different sources and explained it to you. So whenever you are having time, so you can just read it properly with yourself. Some graphs are also I prepared, put it here. So these are the notes for the statistics, and these are the notes for the probability, which I have prepared for both of them. I will be sharing that with you as well. But now the main thing is that you have to understand what is the measures of central tendency. Within the descriptive statistics, we have different measures. Look, we have measures of central tendency. We have measures of dispersion, and we have another measure which is called measures of position. So these three measures are very important in descriptive statistics. So measures of central tendency, what does it mean? Mean, median, mode. So what does it mean? What is the difference between mean, mode, median, mode? So just let me, where to put it? Maybe here, I can just, so now mean is the average value, for example, and mode is median is the middle value when data is sorted, and mode is the most frequent value. Look, just I will paste a picture here for you. This is from a data set. Distribution of sleep times of various mammals, for example, yeah? Hours of sleep. Some mammals are sleeping between 0 to 2 hours, some between 2 to 4 hours, some between 4 to 6 hours, some between 6 to 8, some between 8 to 10, 10 to 12, 12 to 14, 14 to 16, and some mammals are sleeping between 18 to 20 hours. Okay, good. Now, how you will tell me that which of these measures will be good to say, to make a decision that on average, how many hours these a mammal is sleeping? So how do you think that which measure will be good?
Yeah, sir, we will use mean for this one in order to find out the average.
So why you are not using median?
Because it is the middle value, it cannot specifically describe the average. Maybe most of the time it differs from the average. It does not represent the average, the mean. Like if we have like between 0 and 20, so the middle value could be 11 and 10. But the average is something else.
Why then you are not using mode?
Because mode actually represent like which mammals, mostly like that. It's all about the numbers. Like between 8 to 10 hours, most of the mammals they are sleeping. So that's why mode is used for repetition, like which is repeatedly, or it's often happens, like frequently happen. For this purpose, we use mode. But to find out the average, the basic or the most essential measurement is mean. Mode is actually showing the frequent, the frequency actually, or the frequent action happened.
Frequent action happens is the mode.
Yes, sir.
Yes, frequent action is the mode. So it means if you say that okay, mode median is not accurate because not the central one, if is not accurate, okay, then why you are not using mode instead of mean? You can use mode. Mode is, for example, majority of people, yeah, what they are doing.
Yeah, of course. It shows the majority of the people or the majority of the action that happened. But average is something like if we talk about the scores. So majority of the people, of the students, they might get 90%, 90 scores. But there are a number of the students that they are getting less than 90s. And there are some students that they are getting 80s. So we have to collect those all and find out the average, like from less, most frequent, and middle. We have to find a value that represents all of them.
Yeah, but good, as you mentioned, the majority of students, and then you said the mean. Then there is another thing which comes in, didn't come to your mind, that maybe mean is affected by an outlier. Who knows? Yeah, there is an outlier affected, and the mean has been skewed to something very, very huge number. You got what I'm saying?
Yes, I definitely got it, sir. So that's why.
Now let me explain it to you. Thank you for the explanation. But now we will be coming to the from this image, you cannot say that what to use. That's not possible. you have to calculate it. There's the statistics comes in. You have to understand it first, then calculate it, then select which central measure of tendency you have to choose. Mean is the average value in this chart. Median is the middle value when data is sorted. Mode is the most frequent value, the most frequent. Look at this data, for example. This data is 12, 15, 14, 10, 10, 10, 18, 20, 15, 14, 12, 15. This is just the data, just example data. Okay, now calculating these measures. Mean, it's the NP dot from NumPy. You can use the mean. Median from NumPy. In order to find the mode, you have to use stats. This is SciPy. Import stats. This is another model because mode is only in SciPy library, not in NumPy. But from there, you have to bring this library and then calculate the mode for this data. Now look at this. Mean of these values are 14.09 something. Median is 14 and mode is 15. See, look at the data, that how the data is actually distributed, and almost all of these mean, median, and mode, they are together, close to each other. Look at this. It starts from 10. The maximum is 20. See, these are the values that actually. Now let's add 45 here. Now look at the mean, look at the median, and look at the mode. Mean has been increased to 16.6. Why? Why it has been increased? Because a value, which is an outlier, has been added to this data set. Look, all these data is between 10 to 20. This dispersion is very good, but there is an outlier. This outlier actually skews the data set. So it means skewed. It means so it's how to explain it in English? كش میکنه امی دیتا ست امی اندازه‌گیری دیتا ست به یک طرف، یا طرف چپ یا طرف راست، پس آن باز گپ میزنیم. So it skews the data set toward right or left. But this is an outlier. Look at this outlier. This outlier increased the median, the mean. Okay, now you're telling me that you're using the mean of this value. Do you think the mean is a proper central tendency value in this case?
In this case, if we count the outlier, sir, so it is not the accurate one. So
yeah, thank you. I'm just asking anyone else as well. So the mean is actually not a proper measure for this data set, because we have an outlier there. We have to understand where is outlier existing or not existing. So distribution of these things. So from just whenever you're looking at a data set. So in this case, which would be the most appropriate one that you will select for this data set? You have mean, you have median, you have mode. So instead of mean, you can just simply select the median, or maybe select the mode. But ratherly, you can select the median here if you're not talking about the most frequent values, but you're talking about the middle values or average values. So if you're talking about the average values, so the correct or more accurate one will be that one. Now just put it 45, and also put here, for example, let's see if this data set is also minus 20, for example. Let's see how. Look at this.
Sir, may I ask a question? Sorry.
Yes, please.
So I wanted to know that when we inserted 45, so the mean changed, as we all know the formula of it. But why the median didn't change?
Yeah, because the central value is still the same central value. You can just add one more thing. Look at this now. I will explain it to you. Now we inserted another outlier, but toward the left side, toward the minus side. Again, mean changed. Look at this. So having outliers in your data set, having extreme values within your data set, very strictly affects what? Affects the mean value, the average value. So all the time, just don't rush to select the mean. Pay attention to the median as well. You will be, for example, examining different types of value. And then you have to understand that either we have to select the mean, we have to select the median, or how to select these are things. Because if you have outliers, then selecting a mean is not a proper value. There is, for example, if you have a histogram, for example, something, and let's say we have this. So if we have a histogram, we have to understand the distribution of the data. This is the code, yeah. Or just here we can do that. No, let's make it here. Import matplotlib. That's good. Okay, run this one first. That's good. Now plt dot histogram of what? Of data and plt dot show. So this is the histogram of this data. Okay. These are extreme values. See, this is how the extreme values work. In how you can see the extreme values. This is one extreme value. This is one extreme value. This is toward the left. This is toward the right. And this is the majority of data that we're having it right now. These extreme values actually affecting the mean of the data set. So either sometimes it's going toward this side, sometimes it's making it toward that side. So this is how different types of things can be happen there. Now let's do something else. For example, for this data set, let's data dot mean. Just data dot mean or mean value, maybe data dot mean or no, or let's set we have the mean value. Okay. Okay, let's make the color red. So this is the mean of data set, yeah? Now PLT.AXV line, put the median, color, make it green. Look, mean and median are almost there for this data set. And another thing, the PLT.AXV line color, maybe orange. What is the problem? Okay, yeah, it has, okay, these are 3 frequencies. That's now the problem. Mode value, okay, mode of the data. This is the mode of the data. So this orange line is the mode of the data. So if you just add 55, 65, 65, see how the data set, how it will impact the data set. Look what happened. Mode has been changed to this side. Mean, mode and mean almost remain the same. This is mean and mode the same. Sorry, mode and median remain the same. Mean has been changed hugely because of these outliers. But these are outliers. So you see how the outliers affect the understanding of mode and mean within the data set. And why and how you will calculate that properly. But if mode and mean are the same and they are having putting together, you can put it together, then that's not a problem. You can choose both of them, but majorly you can choose, for example, mean of that. But if they're skewed, then in which, for example, now give me, I will give you another, I will not write another data set. I will just bring you this new, instead of this new data set. Tell me in this data set, it's going to the end of the data set. Okay. And this data set, and this histogram. This is the mean and this is the median. Which one you will select? For the measure of central tendency in such a data set, which of these measures you will be selecting? Anyone? Hello, can you hear me?
Yes, sir. I definitely use the median as it shows like this where the central value is much more focused. Again, we have to consider the fact that there might be outliers in the data. So I would definitely go for median.
Exactly. These are outliers, but you cannot eliminate outliers. So if you could eliminate outliers, that would be brilliant. But if you could not eliminate the outliers, then what to do with it. So that's now the thing, yeah. Now another data set, another. So here, not actually someone else. Which measure you will be selecting?
I think mean, because it's like close to all sides of the data, or like the measurements or numbers.
You will be selecting
Mean.
That's it. What is
Yeah,
called,
because
this is called right skewed data set. It means it has been skewed to the right. So look to the right side. This is called left skewed data set.
So actually, sir, here are some outliers.
This is right skewed data set and this is left skewed data set. So these are central measures. Then you have to select these ones based on, and for sure there are outliers as well. So someone asked something.
So actually, sir, I was mentioning like as this histogram or this data set is skewed due to the outliers, so we will go for median.
Exactly. If a data set is skewed, the median is generally a better measure for central tendency. So in this case, again, median will be the proper decision for this, not the mean. The median will be. In this case, again, the median will be the proper decision. You know why? Because in both cases, the data set is skewed. And when it's skewed, it means there are some outliers. This is why it happens. Now coming to the one more questions one of your students asked. I will be okay. Now. Okay, just remove these ones. Remove these ones and remove this one as well. Okay. So and we have a proper data set. Now this is a proper data set. Mode is here, mean and median is here, and that's it. So this is a proper data set. Now look at this. One of the girls asked me, really don't remember, about the mode and median, yeah? Median is the central value.
Yes, that was me.
Yeah, median is the central value. So look, sorry, I have to delete this one. Delete this. I have to just play with this. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are elements within this data. Okay. Now, if you want to find the mode, the median of it, the median of this data set, then you have to sort the data set first. So sort starting from the lowest to the highest. The lowest number is 10, 10, then again 10. Yeah. Okay. These are now deleted. After 10, we have 12. Okay. This 12 is now here. We have another 12. This 12 is now here. Good. After 12, we had 14. Okay. This 14 is here. We have another 14. This 14 is here. After 14, we have 15. We have 115. We have another 15. Sorry, it was not deleted, yeah? Yeah. And we have another 15. After 15, we have 18. And we have 20. Good. We sorted. Now, what is the central value in here? 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5 here. See, this 14 is the central value. This is called median. You got it?
So we count the numbers.
You're counting
and then
it. You're counting. Yeah. 5 this side, 5 this side. Yeah. But now this is something else. If you have 22 here, okay? First of all, you have to sort it. Good. Now, you don't have any central value because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 1, 2, 3, 4, 5. Good. 1, 2, 3, 4, 5. Good. For the center, you have two values. Which one is then the median?
Mm, 14.5.
No. Maybe, yeah, but the scientific way is 14 plus 15.
Divided by 2.
Exactly. Divided by 2. Got it.
Yeah,
This is
thanks.
how this is how you can calculate the median. Now, what is the mode? Mode, most frequent value. 10, how many times?
2.
Okay. 10, 2 times. 12, how many times?
2
2 times.
times.
14,
2 times.
15,
3 times.
18,
1.
20,
1.
and 22 also 1. So
1.
this is the mode here. The most frequent one.
10.
The one with the highest. So this is now the mode. 15 is this is the mode of the.
So have 12. We calculate the mode.
I didn't get your
Okay, I said that. What if for 15 we also have like 215? We don't have, I mean, 3 times 15. Then how we can
then the
calculate the
lowest.
mode
I just did
that
it.
time?
Now
I mean,
look at this. I just did it for you. I know what you before asking. How many times 18 now? Now 3 times. See?
yes.
2 times 10, 2 times 12, 2 times 14, 3 times 15, 3 times 18.
Yeah.
Most frequent value. Most frequent value is here now, both 15 and 18. Which one is the mode? The lowest one. Between 15 and 18,
Okay.
which is the
15.
lowest one. 15 is the lowest one, that would be the mode. Good. Now I think you understand properly
Yeah.
what is the central tendency. Now this is called measure of
Yeah.
central tendency. Now going to the measure of dispersion, which is the range, variance, and standard deviation. These are also playing key roles and playing important understanding of these. What is actually spread of the data? Range, it's the difference between the maximum and minimum values. You had a list. This was our list. This was our list. Just delete these ones. 22 was the maximum value, 10 was the minimum value. So 22 minus 10, 12. Range is 12. For that specific data set, how much is the range? 12. What is variance? Variance measures the spread of data points around the mean. Okay, you have a mean, median, mean, average value, then spread of data around the mean. And what's standard deviation? Standard deviation is the square root of variance. Now look at this. This is the range, 14 to 6, for example. 14 minus 6 is 8. So 8 is the range of the data. You got it? So maximum value minus the minimum value, maximum value minus minimum value, that would be the range of the data set. Okay. Now this is the variance. Look, this is the mean, and these are different values. 3 point something is the mean. 4, so distance, so this is 4, the distance between 4 to this mean, distance between 6 to this mean, distance between this 6, this is another data set, it's also another number 6, between this minus 2, or not minus 2 to mean, 1 to mean, 1 to mean. So this spread of data points around the mean. So this is called the variance. This is called standard deviation. So this is called standard deviation. So you have variance, and why there is standard deviation? Standard deviation is actually the square root of variance. Now assume why there is square root is important here, and what's the logic actually between variance and standard deviation? They are the same thing. This actually measures the spread of the data around the mean. But if you have mean, for example, in 1 here, and there are data points which are minus, negative ones, yeah, minus 10, minus 12, minus 15, minus 18. You got it? So distances that you are having distances, several distances between that data point and between the mean. Some distances actually will be in positive numbers, some distances will be in negative numbers. Whenever you are applying any mathematical calculations on it, mathematics understands that, okay, minus values, so for the negative values, there are specific different calculations. But from variance point of view, actually for us, minus distance and positive distance doesn't play any role. For us, only the distance, absolute value of that distance is actually playing a key role. For us, that is not important, that if it's minus, it's plus, that's not important. For us, how much measures, how much of that interval it is far from mean. Look, in this data set, we had a standard deviation. We had a standard deviation of 0.7. It means on average, each point is 0.7 away from mean. So you have to count these distances, make sum of them, yeah, then take the average of them, dividing it by all those numbers of data points, and see how much on average a data point is far from the mean. That's called standard deviation. That's called actually variance. But because in order to not have a minus value for it, because if you have minus numbers, negative numbers, then it will affect this calculation from mathematics point of view, they introduced a new thing on the variance point. That's called standard deviation. Standard deviation is actually the square root of that number in order to make it positive. That's it. That's nothing else. So from mathematical point of view, that's just nothing. This is how you can calculate the range. See in P dot P to P. This is the range, variances in P dot var of a specific data set. Standard deviation is in P dot std. These are the standard deviation for a data set. Variance 8.6, standard deviation is 2.93. So this is square root of this. So this is how square root of this variance is the standard deviation. Actually, it means that range of data is 10, so it means from maximum to minimum of a data set, there is 10 values. And the variance, the average distance between the mean value and to the specific point is 8.6. This is how the measures of dispersion you have to understand and you have to calculate. The difference between the variance and also between the standard deviation. We have another thing as well, which I will not just put it here because it will make it difficult. There's another deviation called also mean absolute deviation. So there is SD, which is standard deviation, and there is also another measure which is called mean absolute deviation, which is also penalizes each distance equally. So this is how there's another thing. We will not go through that very deeply, but still we have to understand it in that set. Now coming to the data distribution. Histograms, for example, box plots and density curves. So what is histogram? Histogram is actually visualizing the frequency of data points and intervals. So visualizing the frequency of data points in intervals. So we have this interval between 0 to 2, and this is the frequency of that specific data points within that interval. So there are around 100 data point within 0 to 2. This is the frequency of those. This is how histogram works. What's a box plot? Box plot summarizes data distribution with quartiles and highlights outliers. So this is very important whenever you want to understand outliers. And what's density curve? Density curves, it's a smoothed version of the histogram. So this is histogram, but we want to have density curve. So this is the smoothed version of histogram, another variation of histogram. But the basics of the density curve is actually histogram, similar to the standard deviation in variance. Standard deviation is a mathematical transformation of variance. Variance is actually a physical thing in statistics and tangible, understandable things. But standard deviation is just a mathematical transformation. Density curve is the similar thing to histogram. Histogram is the basics of it, but density curve is actually its transformation to proper understanding. So look at this. This is a histogram of the values that, for example, we had. What it means the frequency of data points in an interval. So interval between 10 to 12, we have two frequency. This is the frequency. Now look at this. Where is data actually? Oh, data is this. This is the data. Okay, good. Let's take this data. You should not just. This is our data. Bringing it back in order to understand it properly. Okay, this is the data. So we have between 10 to 12 two frequencies. Am I right? Yeah. So this is 10 to 12 two frequencies. And you know better that in Python, when you're saying between 10 to 12, 12 is not included, it's excluded. Am I right? Do you remember that one?
Yes.
Yes, so 12 is not included. Yeah, just don't think that 12 is included here. 12 is now included in another. 12 to 14, two values. It means two 12 values. One is here and one is, for example, here. Then again, between 14 to 16, so there's 5, 14 and 15 values, for example. So yes, we have 3 15 values and 2 14 values. And then 16 to 17 to 18, we don't have anything. Then between 18 to 20, we have, for example, something like that. But still, this is how 20 is not included in this data set. This is how you just divide it by bins. See, we divided by 5 bins. 1, 2, 3, 4, 5 bins. So you can divide the histogram into bins. This is how. Now the box plot is something else. Look at this. This is the box plot. What is box plot showing here? Box plot showing here, I will just bring you a proper understanding of box plot, for example. What's actually box plot? This is a box plot, see? This is the minimum value. This is the first quartile. So from this is the Q1. This is the median, second quartile. This is third quartile. And this is the maximum value. These are the elements of a box plot. So this is the minimum value here is 10. Maximum value is 20. Now let's add maybe, what do you think if we add 45? What will happen? Look at this. Box plot is now defining to us that there is an outlier. Look, the whole data is there. The whole data is between 10 to 20. Good. Now let's add something here. Minus 33. Okay. Now look at the box plot. Box plot says that there are two outliers. One is minus 33 almost, one is 45 something, and this is the box plot. So just make it a bit lower. Maybe we can just put it 20, and also this 30 maybe, and we will see what happens. Still, this is how it happens. So this is the minimum value, maximum value, the median value, Q3, Q1, this is Q2, quartile, yeah? And these are outliers. Box plots are good whenever you're looking at outliers. Look, in histogram, look at this histogram. From this histogram, you cannot see the outlier, but you can detect only this outlier. See this outlier. You cannot detect the maximum outlier here. See? Specifically, if you put it, for example, bins 5, you just put it 5 bins, yeah? You cannot just actually detect it properly. Just let's remove the bins, see, can we detect it anymore or not? Again, we cannot detect it. See, you can detect this -1, but not the positive outlier. Box plot, the good thing about box plot is actually you're detecting both type of outliers, the maximum ones and the minimum one. So these are very important, as we mentioned previously, that first of all, you have to understand the data properly, and then decide upon which measure you will be using. In order to understand the data properly, then you will have to have some measures. Now, this is the density plot. Density plot shows the density, the majority of values, which are in which interval existing. This is called the density curve. So look at this. So majority of values from, look, if you just put it like this, from 10 to 12 to 20. So the majority of values are between 10 to 20. And 15, the highest number of values is at this 15. And that's right, because 15 is the mode of this data set. Look at this. 15, 15, 15. This is the mode of this data set. Still, we have 18 as well. Look, we have 18 as well, yeah? So 18 as well. But 15 is actually, from density curve, you can understand the mode of the data set. So which central tendencies. So all of them, these are the things that you can understand something from it. So this is the histogram. You can understand the mean value or median value for it, but in order to properly decide which value you have to select, you have to have the box plot. And the median value, the mode value of the data set, and see which majority of numbers in which interval are existing. This is the density curves comes in. This is how you have to deal that. Now, how to identify the outliers and how to deal with the outliers. This is another good thing that you have to understand it.
Sir, I have a question. Quick one.
Yes, please.
Is this density curve that we're talking the KDE plot?
It's yes, it's kernel density. And the KDE plot is also that one. And this density curve is also the same one. But it's look, we already plotted this somewhere else, if you remember, yeah. In our ED report, yeah, in our ED report, and there was a histogram and there was a density curve. We plotted both together. As we mentioned previously, that the histogram is actually the basic one. In the density curve is actually the transformation of a histogram into a smoothed one. Yeah, to understand that. And why we are doing it actually, because in histogram it's a bit difficult to understand, as I mentioned, the mode of the data or the median of the mean of the data. But from density curve, this area under this curve is very playing a key role. Whenever you're going to study, you're coming toward the probability, then you will understand the confidence interval. Yeah, how much confident you are, for example. If you're predicting something and that is between this area, a data point which sits in this area. So how much you are confident of it? Yeah. So this is the level of interval of confidence, for example. So we will learn it separately, but this is KDE. That's it. And now we're coming to the outliers. Outliers are playing a key role, and I know that you have a proper understanding of outliers right now as well. But still, first of all, if we have Q1 definition, outliers are extreme data points that differ significantly from other observations. Extreme points which differs from other observations. So majority observations are in one point, and this is which is extreme value which differs significantly, then that observation is called outlier. They can skew the mean and affect analysis. This is the problem with the outlier, as we already saw above. So now Q1 is this is how you should first quartile. So you have to calculate the first quartile. This is Q1, for example. Quartile 1 is in P percentile. You have to put data 1, and then first quartile is 25%. Q3 is data set with 75%. What is the interquartile range? This is called range, as you mentioned. So the Q3 minus Q1, that's called IQR. Now define outlier boundaries. Look at this. Lower bound, Q1 minus 1.5 multiplied by interquartile range. Upper boundary is Q3 plus 1.5 of interquartile range. Now you will see that how the outliers for this data set is actually. So we have lower bound 3, upper bound 27, and there is no outliers in this data set. This is the data. This is the data. What is lower bound? It means if a value is less than 3, it will be treated as outlier. Or a value is less than 27, it will be treated as outlier. You got it? How you have to find the maximum value for an outlier in the minimum boundary. So where to find the boundaries? Now coming to this point again, look at this. This is the Q1, 25% of data, yeah? This is Q1, 25% of the data. This is Q3, starting from here to here. This is 75% of the data. Q3, 75% of the data. This observation, which is this one, yeah? Minus this observation, which is this one. Look, somehow for 13, yeah? 13 minus 8, just assume that it's 8, yeah? 7.5, maybe not 8, just assume 8. So this will be the interquartile range. It means this is the range. You want to find this range actually. Then what to do? 1.5 of this range. 1.5. It means this range is if it is maybe 5, 6, 7 multiplied by 1.5. Input it from here. 1.5 of this IQR from quarter one, in 1.5 of IQR from quarter 3 toward this side. So one and a half of this distance to above and 1.5 of this distance to below. This will be the minimum boundary and maximum boundary for the outliers. More than that boundary, it will be calculated as outlier. Less than that boundary will be calculated as outlier. Now look at this. For this data set that we had, yeah? So we have marks of students between 10 to 20, yeah? This is how we had the marks of students. This calculation shows that lower bound for outlier is 3, upper bound is 27. So if I add, for example, 25 here, it will not be calculated as outlier. See, it is not an outlier. It affects the upper bound, lower bound. That's not a problem. But just assume for this data set, the upper bound is 27. But if you just add, for example, 35 is an outlier. See? Or, again, original data set. Lower bound is 3. Okay, put something, for example, 1. 1 is outlier. Got it? That how you will find the outlier. Right now, we don't have any outlier. This is perfect box plot. See, there's no outlier. So this is how you have to find outlier. In some cases, whenever you're doing data engineering, this 1.5 is not freeze. Sometimes you can increase it to 2. Some people, they're increasing it to 3 even. It depends on how much data because whenever you're putting this formula, you will be deleting some data actually, yeah? So the data which is out of this boundary will be not considered. It will be deleted. So you have to be very accurate and very cautious whenever you're dealing with not calculating the data and not taking the data into consideration whenever you're doing any analytics. That's playing a key role. That's important. because in some data sets, even outliers are playing a key role. You have to understand the outliers, for example. Yeah. So whenever a real estate data set, you're calculating a real estate data set. Real estate data sets, you would be having some luxury properties, for example. Yeah. But those luxury properties are very less in numbers. They're very few in numbers. For example, maybe 2, 3, 4, or 5 properties in a data set of, for example, 100. So if you're just eliminating that those outliers, it means that you just eliminated a whole category of data, which is the luxury real estate data, and you're not calculating it in any data. You're not keeping that into consideration. This is how you have to be cautious and make proper decisions whenever you are analyzing data as a data analyst, that either you want to keep it or not keep it. This is the basics of statistics. Now coming to the probability, I really don't know. Should I go proceed to the probability or not? But I don't know how is the mood of the students, but we have to proceed with the probability. Before the probability, I just want to mention that just forget about probability. Probability is a bit complex name. Whenever everyone is hearing says, "Oh, it's very difficult. Probability is very difficult." Well, that's not difficult. On daily basis, you're dealing with probabilities, but you are not actually considering it as a probability. You're not looking at it as from a mathematical point of view. Whenever you're just looking at from mathematical point of view, then that would be a probability. Look, everyone says chances. I have this much chances. Yeah. So everyone says chances. So those chances are actually the probability. Yeah? So this is how. So what is actually probability? Probability is the likelihood of an event occurring measured between 0 and 1. Either 0 is impossible, 1, which is 100%, will certainly happen. For example, I have a chance to pass my exam. I have a chance of 60%. Yeah. So it's 0.6. This is the probability of this event that had to be happened, which is my chance or my probability of passing the exam. It is actually 0.6. Or flipping a coin. So just coin, you have a coin, just flipping it, yeah? 𝗔𝗱𝘃𝗃𝗃𝗃𝗃. So P hits, it means 𝗔𝗱𝘃𝘃𝗃𝗃𝗃 from hits, 𝗔 So how much is the probability whenever you're tossing a coin, flipping a coin, how much is the probability that you will get a head? 50%, yeah? So this is 50-50. The probabilities of 50%, there's a chance that you will get head, 50% chance that you're not getting. So this is how there are two possible outcomes for this tossing a coin. You know, two possible outcomes. This is how the formula. Either it is head or not head, yeah? So this is two possible outcomes from this flipping a coin. Now you want to know the probability of only heads, one of them. So this is 1 divided by 2. 1 divided by 2 is 50%. Simple math. So this is probability. Okay, I know, but maybe that's not that much. But let's go something else. Now, tell me the probability of, these are the salespeople in a company. One name is Amir, Brian, Claire, and Damian. So tell me, actually, what is the probability of assigning one of these peoples?
25%.
25%.
Oh, you're brilliant. So now, see, everyone is actually just understanding how much is the probability of assigning, for example, one of these people. Just assume, for example, if you want to assign Uh, I really don't know why it's going to the end again and again and again. So if you want to pick up Brian, then the probability of Brian is, so we have, look at this. How many possible outcomes are there?
Four.
1,
Four.
2, 3,
Four.
4. 4 possible outcomes. Selecting one of them, either Brian, Amir, Claire, or Damet. One of them, yeah? So what? 1 by 4 is 25%. So the probability of this is actually 1.4. So you got it, yeah? Now, coming to the another thing. This was our first meeting, yeah? We had our first meeting, and we select a guy from this. Okay, we said, okay. We selected. Amir is selected. Now for the second meeting, what happened in the second meeting? In the second meeting, now we don't have, sorry, Brian is selected. For the second meeting, now we don't have Brian. Okay? And the second meeting, we don't have Brian. Now, if I want to select another one in this meeting, how much will be the probability?
It's going to be
2.3%.
1/3 or 33.33%.
In order to select another thing, another one from this group, it will be this is a problem with the colon. This will be actually because right now Brian is gone. This is called sampling without replacement. It means you have a population, you got a sample from it, but there is no replacement to that sample. It is scattered already. Okay? Some people, if you're asking, okay, what is the probability of selecting Amir here? Okay? Everyone will say 25%. And you will say, okay, good. Now, what is the probability of selecting Brian here? Everyone will say again, oh, 25%. That's wrong. See, this is how mathematics works. Because you already selected Amir. Amir is not there. For Brian, the probability is now increasing. It would be 33%. You got it? So I hope you got it. There is no confirmation. I hope you got it. But this is how, yeah, this is how the sampling without replacement works in probability. That whenever you're asking someone, okay, how much is the probability of selecting this guy? Everyone will say 25%. How much is the probability of selecting this guy? Everyone says 25%. No, because we have sampling without replacement or with replacement. So what is the question here actually? You have to ask in this with the same data set, do we have with replacement or without replacement? If with replacement, then we already picked someone. Without replacement, we already picked someone and there is no one there. The space is empty there. So the probability is increasing for choosing another guy there. So this is called without replacement. And if we have a selection with replacement, then it means the probability will remain the same. It means these two events are independent. We are coming to the dependent events and not the independent events. If you're selecting someone from here for the first time, then selecting from that specific data set the second time, so without replacement, there is no replacement for Brian. Brian is gone. Now from these ones, we have to select someone. Then this is called without replacement. This is called dependent events. So this event was dependent on this event. But what's independent event, that we have this data set, we selected Brian, but we replaced Brian with another guy, with Ahmad, for example. Now, second event, the chances again 25%, yeah, because we have a guy here already. Ahmad is replaced the Brian. Now, I want to know the probability of choosing Claire. Claire will be still not 33%, but 25%. So one is with replacement, another is without replacement. So this is called independent events if there is no replacement. So these are independent events. These are important in the probability. Two events are dependent if the probability of the second event is affected by the outcome of the first event. And independent events if the probability of the second event is not affected by the first event. This is how the probability works. So I think this would be about the probability, number of favorable outcomes and total number of outcomes. This is the main formula for probability. This formula. What is the total number of outcomes? In which outcome, for example, 3 here, yeah, this is the total number of outcomes. And we're selecting one, then that will be one. But this is the total, this is the formula. Addition rule for this is how to add probability events, even 1 and even 2. So this is the addition one, and the multiplication one is also this is the multiplication one for the probability. Now we will be introducing probability distributions, binomial distributions and normal distributions. You'll be doing this tomorrow, hopefully. And this is, for example, total outcomes. If you have a 6-sided die, yeah, so we have a cube of 6 sided. So we have, and we want to, you're just rolling it, yeah. Rolling outcomes will be 1, yeah. So how much will be the probability of rolling a 5? 16%. See, probability of rolling a 1 or a 5. So probability of rolling a 1 by total outcomes and 5 by total outcomes. A 1 or a 5 is actually 1 plus 5. This is the addition rule in probabilities. You got it? It will be 33%. And probability of rolling 2 5s, it means we will be having 2 5s. You got it? And that will be the multiplication of these 2 1s. So outcome of 1 by outcome of this one, and then you have to multiply these 2 1s. That will be 2 5s in a row. That will be 0.03. So 3% is possible that 2 5s will be there. 33% is possible that there will be either 1 or 5. And 16% will be possible that there will be is a chance that only is, we rule and there will be a 5 there. So this is how you have to understand the multiplication and addition of the probabilities. 1 or a 5. So it's not like mathematics. If you're saying, I want to know the probability of 1 or a 5, you have to add these two probabilities together. You have to calculate the probabilities for outcome 1, then probability for outcome 2, then add it. Or if we have 2 probabilities, it means you have to multiply it. This is how the multiplication and addition rules work in probability. Coming to the questions. Sorry, maybe it was very frustrated presentation and discussion. This topic is a bit complex, but still, I hope you will be learning it step by step. Okay, I think there is no questions here. If you need questions, please ask me.
Sir, I have a question.
Please.
In the calculation, in the statistics, if we delete any outlier from a group of data, so there are, for example, there are different variables in a group of data. So if you delete one or two outliers from the data, do they affect the result of the data? Like, for example, we have replications in different variations, no, in different variables. So from one variable we have 6 replications, and from others we have like 8 replications. So while calculation, does it affect like
Yes.
deleted
Whenever
outlier?
whenever you're deleting outliers, it significantly impact the result of the data analysis. I told you previously, and I showed you mathematically there, that whenever you are deleting the outliers, it affects significantly even the outcomes of the specific data. So the upper bound, the lower bound, the mean, the median, everything will be affected with having the outliers. So all the aspects of a data will be affected by deleting an outlier. This is why it's very important that you have to understand that when you have to delete an outlier. This is I give you an example of real estate properties data set. Yeah. So and when you have to decide that when you have to delete the outliers, for example, if you see that maybe there are data errors there, so these extreme values are maybe due to the error are there, for example. See, for example, in this data set, we had 15, there was 45. 45 is an outlier, but maybe you have to analyze it first that maybe this is not 45. Who knows, maybe this is a data error, maybe this is 4.5, for example, or maybe something else. Yeah, so you have to assess it in that way as well, that maybe that's a data error. Then after that, you have to understand maybe that this is irrelevant. Maybe this data point is irrelevant. So irrelevancy is also playing a key role. And then you have to do some analysis, sensitivity analysis. So we will be coming to that where we will be using sensitivity analysis. Other methods of detecting outliers will be coming in probability. That's called Z-score method. Different things. So yeah, it impacts, and please be very careful whenever you're deleting outliers. You have to understand the outcome of outlier on your data set.
Okay, thank you.
You're welcome. Any other question? There was another guy also raised the hand and then lowered
It
your hand.
was, but like my question was the same, so it's answered.
Oh, good. That's good. So I hope everything is understood, and it's okay. And this is now the end of our lecture for today on statistics and start of probability. We will be continuing probability tomorrow. And please don't miss these classes, because I'm trying my best to explain it in a very simple way. But if you started reading it by yourself, it will sound very difficult. Well, it's not difficult, it's very easy. But sometimes whenever you're studying technical things, so it sounds very difficult, very complex. Well, that's not that much complex. Thank you for your attention, and thank you for your participation. Our lecture is completed today. We will be meeting you tomorrow. تشکر از شما. سوال باز داشتین سوال کنین. اگر راجع به موضوعات قبلی کنم بحث‌های کارخانگی چی سوال داشتین رو باز برای ناشته کنیم. تشکر از شما. یک سروی رو دکتر سیب روان کرده بودن در گروه که شما از امی برنامه ما رو چطور ارزیابی میکنید، لطفاً اون رو فراموش نکنید که او را روان کنیم. به خاطر از او که ما سروی میکنیم که برنامه خود بهبود بدیم، از او خاطر او را هم روان کنیم. کسایی که به انگلیسی گپ نفهمیدن، امی تشریح امروز که ما دادم در استاتستیکس و احتمالات probability را باز اگه سوال مخصوص دارین مشخصا در گروه روان کنین. من حتما کوشش میکنم که براتون جواب بدم. ما رو به الله میسپارم. خداحافظ شما. Have a good evening and day. Bye.